So now we're going to move on to our 10-minute discussion period. And so we have some folks, they've been typing questions into the Q&A. And so I'm going to read a few of those questions and also ask a few of my own questions. And so all of the speakers for the morning, so that includes me, Jamie, Adam, and Clive, in addition to the folks who just presented in the most recent section. So if you have questions for a particular speaker, please say that in the Q&A. So I'll go ahead and take a look at the questions. One of the questions from Keisha Rogers is, how will collecting samples on the moon be different during the Artemis mission than with Apollo? And I think this might be a good sample tool question. So I don't know if Adam is online and can talk about some of the differences in the sample tools between Artemis and Apollo so far. Is that something you can take, Adam?
Sure. I think in terms of how everything is going to be taken, I think the process will be similar. There will be a pre-sampling phase where there will be observation and just describing what they're seeing, taking pictures, and then the process of sampling, at least with the tools I described earlier, is going to be very similar. We're looking to add some functionality to the tools to make them easier to use, and we want to try to provide the capability for a single crew member to perform end-to-end sampling ops by themselves. So that's a new capability we're looking at. I'll leave it there.
Thanks, Adam. The next question is LRO LEND data appears to indicate that hydrogen, presumably water, is widespread near the poles rather than concentrated in PSRs, with average abundance around 0.14 weight percent. How will it be distinguished from contamination? I can take a stab at that. That's a really good question. I think one of the things we're going to have to do very well is our contamination knowledge, and making sure we don't just have contamination knowledge for particles, but also for volatiles as well. And so if we can very well characterize the especially isotopic character of our terrestrial water that we're bringing with us, either from the suit or from the spacecraft, then we can compare that with the isotopic signature that we collect in the samples. If they just so happen to be the same, then it will be very difficult to distinguish the two, unfortunately. But I imagine there will be some differences, especially if the water in PSRs is of cometary origin. It should be very distinctive isotopically from what we would bring on a spacecraft. So do any of the other speakers want to chime in on that?
Yeah, I'd like to chime in on that. This is Clive. The issue that I see, can everybody hear me? It looks like it's working.
Yeah, we can hear you.
Okay. Let's think about the gardening aspect. If you look at LRO LEND data, they're looking at they're integrating details across the top meter or so. So looking at subsurface hydrogen. The contamination that we've had from spacecraft that have been going to the moon for the last 50+ years is going to be concentrated in the surface, because the gardening to get them down to that level probably hasn't occurred yet. So I think that then looks at preserving the stratigraphy of drill cores, and then being able to examine the stratigraphy in terrestrial labs, or if there is some way to do it on the surface, that's another way to look at it. So I'm a bit more optimistic that this is not contamination, because it is looking within the subsurface. But we have to test if these data are actually telling us something about a potential scientific and exploration resource, or is it an artifact? And I think that's more along the lines of what we're looking at here. So being able to drill down and actually get ground truth those measurements it could be very enabling.
Great. Any other speakers want to chime in on that one? Yeah.
Oh, Julie, this is Brad. I just wanted to comment quickly. Jack and Gerardo both had some very interesting comments that also bear on this. Clive nailed it. We need to have cores that we can seal well and that preserve stratigraphy, because contamination ought to be at the surface. But I think it would be a combination of things. And Gerardo brought up the possibility of collecting, sequential release materials. We have to think about all these approaches and maybe do multiple kinds of things to really identify what's contamination versus what's indigenous and characterize the diversity.
And what is feasible technologically and with fiscal reality. So that's the other thing that we need to think about and be inventive in our approaches.
Yeah, wet blanket.
This is Jack. Can you hear me?
Yes.
Yep, we can hear you, Jack.
Yeah, just two things I wanted to add to the relative to the first question, and that is two major differences in the sampling environment will be lighting. High latitudes, you're going to have much less backscattered light into your shadows and a lot more shadow. And secondly, if you indeed do have water ice in the regolith, it may well, almost certainly will make the regolith much more impenetrable than it was even in low latitudes.
That's a great point, and I think that's where I'll give credit to Adam and Heather Bergman and her team, because they are actually looking into that for the drive tubes in particular, to make sure we understand how much of an impact the presence of water ice especially, but other volatiles will have in terms of the effectiveness of collecting those subsurface samples. So that's absolutely a great point. Okay, I had a question for Judy. Judy, you talked about the negative pressure glove box that was originally used on the first few Apollo missions. One of the things we've been thinking about for curating some of the volatile-rich Artemis samples is having negative pressure, specifically because we expect there to be some hazardous components, volatiles like H2S, potentially hydrogen cyanide, ammonia, other things that you don't want to have coming out of the glove box, which you would have potentially under positive pressure. And so we're thinking negative pressure might be the way to go there. But I'm curious what you think about just notionally the application of maybe not vacuum, but at least negative pressure for handling some of the volatile-rich Artemis samples.
Wow. Well, in general, you're open to those same reasons that you can contaminate your sample if you have a failure of anything, especially if it's a glove box. Perhaps you ought to think more about taking a sample and subdividing it into different tracks for handling, so that if you do handle things at low pressure, it's not your entire sample. I think, though, the high vacuum was really what drove the complexity up on the vacuum glove box. So slightly negative pressure is probably different. But you saw the pictures that I had there taken from the LRL. There was the negative pressure and the positive pressure glove boxes, the same glove boxes, you just changed the pressure. The vacuum glove box actually had an interstitial pressure. They were pumping from the interface in between the vacuum. So that might be one way to look at it. Does that help?
Yeah, that does help. I think, I think the subdivision of samples is something that we're also talking about for Artemis, just because, we're not going to have, or at least we don't think we're going to have an in situ separation of the volatiles from the solid or silicate, regolith type component. And so we might have to do that separation when we get back to Earth in order to curate the samples and keep them from reacting with each other. And allow us to handle the samples safely. So I think, your point is a very good one, because it means that if we want to be able to handle some of these more volatile rich materials, we need to consider the effect that's going to have on the entirety of the sample and not just the volatile component. So thank you for that.
Julie, this is Chip. There must be, they abandoned this vacuum system for the dry nitrogen system for numerous reasons. Some of it was just the inability to work in that type of environment. And also, I think it broke down at least some of the time. And there must be additional documentation at JSC that documents some of the issues that they needed to address for the system.
Chip, there's a very good reference on my last slide, a paper by David White, written slightly after I think I've forgotten the date, but it was some time ago. And he makes the point that a lot of the failures in that complex system were operational failures that they could improve, like backstreaming of organics from all the pumps and that sort of thing, and streamlining the time it took to move samples through the system because it was very slow with all the procedures that had to be followed. Anyway, it's David White, it's Apollo Experience, and it's Vacuum Complex. You can get that online. His point was it wasn't as bad as most of the geologists thought, especially those that observed the dynamic implosion of the gloves, and that they had worked on the reliability and got it in better working order. But by then, we realized that the lunar samples could safely be stored under nitrogen.
All right. Thank you, Judy and Chip and everyone for a fantastic, and Jack for a great discussion section.